Hello, welcome to Group 69, Software Architecture and Design, Assignment 7, Group Project Presentation. Now in this demo, we will go over how we address the new customer requirements and demo the functionality of our design. Before we go into details, I would like to introduce the team members. In our team, we have Anita, Ankit, Dean, Divya, and Z. So this project has some new requirements that were mentioned in the assignment document. Some of the key requirements are we need multiple mowers that are working together on one lawn. Also, now mowers can talk to each other and share data. We also have energy units for each mowers, and each mower action corresponds to some units of energy points. Mowers can go to energy stations to recharge. Another requirement is now we have gophers instead of craters on the lawn, and those gophers can move. We also have user interface to run the application. This is the updated class model diagram that we have, which identify all the relationship between entities and the logic of how the state of the lawn is changing and how the mowers interacting among each other. We have added some new classes, which are shared channel. We added gophers and also controller class to our diagram. This is our sequence diagram, which shows how the controller layer interact with the service layer, which further integrates with the simulator system to fetch the information. We also provided use case diagram in which we identified various use cases, like when a user is uploading a file, different validations, actions of mowers, like when the mower moves or collide or mower gets stopped, and gopher actions as well. This is the deployment diagram that depicts how we are deploying our application on the virtual machine that we are using to run our application. Now from here, we will move on to our demonstration that includes a quick demo of the application and also talk about some of the requirements and assumptions that we have.
For the user interface, we had a tight deadline, so we aimed to create a simple yet functional user interface that would suit the needs of our customer as well as the assignment. We started by creating some wireframes. We used a tool called Balsamiq and created two versions of the user interface. We then worked together to streamline it and pull the best pieces together. Okay, I'm going to proceed to load the application. Okay, when the application loads, firstly you have a splash page that gives you some information about the application. It welcomes you to the application, gives you some background on the team. It then gives you some instructions on how to proceed, including some information about the specification of the input file that's used to drive the simulation. It also gives you some instructions below on how to proceed and start with loading the input file. The screen itself is very simple. It's a single screen. It has a section at the top that will show you the lawn shortly. It's got a section where it shows you some buttons below. Then it has a section where it will give you information about the states of the simulation. It will give you some information about the summary of the simulation, and we also feed some output to the bottom of the screen that's also directed to the terminal. The application itself, as you can see, is run from the console using a command line. We do need to run the -EA switch because we have asserts within the application. So let us proceed. So firstly, I'll just run through a use case where we give the user some information about error handling. If we load a file, so basically click on the button to load, I've got a sample scenario where the width is outside of the bounds of the allowable width, If we load that, you'll see at the top here, it gives feedback to the user stating that the width of 100 must be smaller than or equal to 15, which is the upper bound. So that is an example of giving some feedback to the user in terms of error handling. We'll now load a demo file. As you can see at the top, we show the lawn is loaded. It gives you the assets of the gophers, lawn, mowers showing in their correct directions. It also gives you the information about the states of the simulation at the bottom. It shows which of the objects will be polled next, gives you their directions of each of the mowers, gives you the energy levels of the mowers. Then on the right we have the summary information on the lawn, gives you the size of the lawn, the number of grass squares that have been cut, the number of grass squares remaining to be cut, the number of simulation turns, the number of turns remaining. So to proceed in terms of the application, there's a couple of ways you can proceed. You can hit the next button, and as we hit next, you'll see the simulation updating as well as the information at the bottom. So click next. It ran the first mower, and you can see at the bottom here it's giving you information about the operation it took and the output of the operation. If we hit next again, it's ran the second mower. It tells you here that the next one, it shows you the next mower that it's going to poll. If we keep going, you'll start to see the mowers move as they start moving. You will also see the additional assets in terms of the requirements of the assignment, where we have the charging unit, and the mower has proceeded to move in a north-west direction. Keep going, you'll start seeing the mowers move. Then shortly you should now see the gophers start moving after their turn duration in terms of the simulation. There we go, we can start seeing the gopher move top right, and we should see the top left move. There we go. At this point you can keep hitting next until the end of the simulation. You can also hit the fast forward button. This will basically play the simulation through to conclusion, and you'll get a final report that's printed out. So we'll just hit the fast forward. There we go, you can see here at the end it's giving you a report printout. It shows the gophers at the top basically staying on the simulation. It shows you the squares that have been mowed. Those are empty, including showing you the original charging stations. Okay, I'll now run through a use case where we will use the fast forward button with the same scenario file. So let's load it. Okay, so rather than hitting next, we will now hit fast forward. This will just run you to the end of the simulation, and you have a printout of the report at the bottom. You will notice that the number of grasses cut is slightly different, and this is because we have some randomization in our algorithm. I'll now proceed to show you the use case where the user will hit stop. So we'll just load the file in again and open it. So we'll hit a few nexts. Okay, at this point I'm going to decide to stop, so we should get a printout of the current simulation. There's the printout at the bottom, and then as you can see the printout matches with the summary information on the right, and you still have all the information on the left of the simulation, the state information. So that concludes the demo. Just in conclusion, on behalf of the team, this group would like to thank the Professor Dr. Moss, Ray, and all the rest of the TAs. We've really enjoyed the course.